there are actually a lot of wildfires in California. And the result of fires is carbon dioxide, and that's why you see all these red spots. It's from the wildfires started by that reveal party in California, and a lot of people are actually losing their homes over here. It's a sad time, 2020, right? Okay, look at India and China's industrialization. Okay, these aren't any fires. It's just that these countries are actually going through their industrialization stage. They're burning a lot of fossil fuels to help fuel their and drive their economy. All right. Okay. Okay. If you guys want to explore this app some more, you guys can. Windy.com. All right. Okay. Now ecosystems. Okay. Because of climate, due to the uneven heating of the earth and the diffusion of energy, all right, it creates most of your major air currents, your ocean currents, and how they react with the huge land masses will create most of the major different kinds of ecosystems on the planet, all right, from tropical rainforests to temperate forests to frozen tundras to deserts, all right, freezing cold deserts, okay, whatever the case. Now, like I said earlier, because of Hawaii's large land masses, mainly on Maui and the Big Island or Hawaii Island, we do have almost every ecosystem known on the planet. Okay, we've got our tropical rainforests, we've got our deserts, our rocky deserts, okay, all of your coastal and oceanic ecosystems as well. Okay, now here are some terms you need to know. Niche is an organism's job, basically. Okay, what it does. Okay, is it a top level predator? Is it a producer? Does it eat plants? Is it a herbivore? Okay, whatever its job is it a fungi, a decomposer? Whatever it is, that's the organism's niche. Okay, next is resource. A resource is a necessity for life. All right, examples are water, nutrients, light, food, and space. Okay, do understand that in nature, not all species are as successful as we are. Okay, we are so successful that all of our resources can be gotten very easily. Okay, out there, if you don't get a resource, if you're an organism in nature and you don't get a resource, most likely you're not going to survive. Okay? Resource, any necessity for life, all right? Such as, again, water, nutrients, light, food, and space. Okay, now there are two kinds of ecosystems. You've got terrestrial ecosystems, which is land, okay, and then you've got marine ecosystems, okay, in the ocean or on the lakes, aquatic, all right? Okay, terrestrial means land. One way to think about it is like ET phone home. You guys too young for that movie? Okay, ET meant extraterrestrial, so he's like extra out of this land. Okay, but yeah, it's a classic movie. ET phone home. Okay, now there are three main kinds of interactions. Okay, you've got competition. All right, when the same or different species attempt to use the same resource. Anytime two individuals attempt to use the same resource, it's competition. Okay? And remember, in nature, if you compete and you miss on a resource, most likely you will not survive. Okay? Humans are one of the only species that are so successful that all of our resources are easily gotten. Predation. Okay, one captures and feeds on the other. Okay, it's a very quick interaction. Okay, you have to capture and you have to feed on the other. Okay, next is symbiosis. All right, there are actually three different kinds of symbiosis. Okay, and I'll cover them next. Okay, now symbiosis is defined as any relationship in which two different species, okay, it has to be two different species that live closely together. Okay, your three kinds of symbiosis. Mutualism. Both species benefit. All right, kind of like Finding Nemo and the sea anemone, right? The Finding Nemo lives in the sea anemone, and there have been studies where it does show that the clownfish actually takes care of the sea anemone. It grooms it. It cuts off diseased tentacles. It picks off parasites. Okay, it actually takes care of the sea anemone. And of course, the sea anemone will protect the clownfish. So that is called a mutualistic um, mutualistic beneficial symbiosis, mutualism. Okay. Next is commensalism. One species benefits and the other is not harmed or helped. All right, helped or harmed. Ooh, kind of dyslexic here. Example of this can be, sharks. Sharks swim, and then you see the remora fish. They kind of swim next to the shark, and they have this suction cup head, and they kind of suck onto the underside of the shark. So basically, the remora doesn't do anything for the shark. So the shark is unaffected, maybe even annoyed. Okay, but unaffected. All right. However, the remora will eat the scraps that the sharks leave behind. So in this case, um, commensalism, the shark is not affected. The remora fish is benefited. Right, it benefits from this symbiosis. Okay, last one is parasitism. Okay, there are a few key things that define parasitism as opposed to just regular predation. Okay, one organism has to live on or in the other organism. Okay, so that's the key thing there. If it doesn't live on or in the host, then it's basically just predation. Okay, to make it a case of parasitism, it has to live in or on the host. Okay, now the parasite obtains all or part of its nutritional needs from the other organism. Okay, so key difference there. Okay, there's what's called a ecological succession. Okay, it's a series of predictable changes over time, and you can even predict this with like the field. You guys all live in Kapolei. There's that field up by Walmart. All right, and I noticed that sometimes they kind of mow the lawn. All right, so as soon as they mow the lawn, what happens next is all these small grasses first grow. Okay, and then these grasses will overtake the place, but eventually there may be a larger plant that grows there. Okay, and then there will be more of these larger plants that grow there. Okay, and then eventually there will be bigger trees that grow there. Okay, and then of course the government sees this and then they cut them all down again. Okay, so just like a field of grass, you can predict changes. All right, in nature, the same thing happens. If there's land somewhere or if there's space for organisms, it will go through what's called ecological succession. All right, a series of predictable changes. Okay, this is an excerpt from the textbook. Okay, ecosystems are constantly changing in response to natural and human disturbances. As an ecosystem changes, older inhabitants gradually die out and new organisms move in, causing further changes in the community. Okay, just like the example of the grass field I just gave you. Okay, on land, There's what's called primary succession and secondary succession. Okay, primary succession happens when there is fresh land. Okay, there is zero signs of life there. All it is just land. Okay, abiotic earth. All right. Now, over time, it will get colonized. Okay, there are only two situations in which I can think of where primary succession will take place. It's when a new volcanic island erupts from the ocean, or when a mile deep glacier has slid off and melted away, causing land to be revealed. Okay, so other than that, primary succession does not take place too often. Okay, succession happens when there's a disturbance. All right, either a human or natural, doesn't matter. All right, starts with whatever was left behind because it was just a disturbance, not new fresh land with nothing living there. It's a lot easier to colonize. All right, so secondary succession happens a lot faster. Okay, examples here is forest fires, storms, knock down trees. All right, and of course with space, secondary succession will take place. Okay, succession also happens in the marine environment, in marine ecosystems. Okay, however, unlike land where you can get new land, I don't think there's a way you can have an area with new water. So in marine ecosystems, there's no such thing as primary and secondary succession. All right, succession just happens. Okay. Okay, and it looks like that's it for today for ecosystems.